Children, today our teaching topic is irrational numbers. Irrational numbers are those which cannot be expressed in the fraction form, that is p by q form. They neither terminate nor do they repeat. They are also known as non-terminating, non-repeating numbers. In other way, a number root x square root of x, where x is a positive and x is not perfect square of a rational number, is not a rational number. As such, root x cannot be put in the form of a by b, where a belongs to z, comma b belongs to z, and b is not equal to 0. Such numbers are called irrational numbers. Thus, the numbers derived from rational numbers that cannot be put in the form of a by b, where a belongs to z, b belongs to z. And b is not equal to 0 are called irrational numbers. Example, pi. Pi is a famous irrational number. Pi is equals to 3.1415926535897 93288462264, etc., and more. We cannot write down a simple fraction that equals pi. The popular approximation of 22 by 7 is 3.1428571. 42857 is close but not accurate. An irrational number is a real number that cannot be expressed as a rational of two integers, ratio of two integers. When an irrational number is written with a decimal point, the numbers are after the decimal point continue with no repeatable pattern infinitely. For example, irrational numbers include pi, which starts with 3.1459265, etc., and is never ending number. Square root of 2, 3, 7, 11 are etc. are all irrational numbers. Root 2, root 7, root 13, root 17 are all positive irrational numbers. Similarly, minus 3, minus root 3, comma, minus 5, minus root 5, comma, minus 11, minus root 19 are also irrational numbers, which are negative irrational numbers. But numbers such as root 9, root 81, root 25 are not irrational. My dear children, observe on the screen how we represent root 2 on a number line. After examining this, we will see stepwise explanation. Draw a line, take a compass, yes, you mark 1 unit right and 1 unit left. From 0, right unit you take as positive 1, left unit you take as a negative 1. This is positive 1, this is negative 1. Now, take protractor and draw a perpendicular. This is a perpendicular line which is exactly perpendicular to the number line. Now take a compass again and draw an arc from 1 to a perpendicular line so that it intersects at exactly 1 unit. Now 0 to 1 is 1 unit and 1 to the line intersecting point is also 1 unit. 1, that is 1. And this is a right angle triangle. We have taken a perpendicular. Therefore, it is root 2. Then take compass again. Measure root 2. And draw an arc from the same point till it intersects the number line. Yes, it intersected the number line. And then mark it as root 2. This is the distance from 0 to that intersecting point of that arc is root 2. Mark it as root 2. And we have represented root 2 on number line. Now, from that root point root 2, draw another perpendicular line with the help of protractor. Yes, now take compass again. Measure 1 unit and draw an intersecting point on the perpendicular line. Yes, exactly. At 1 unit, it intersects the perpendicular line. Then mark it as 1 unit. Now, from where we have started 0 to root 2, the length, horizontal length is root 2. Adjacent side is root 2 and opposite side is 1. Now, join the point 0 to the intersecting point on the perpendicular line, which is equal to root 3. 1 plus root 2. 1 square plus root 2 whole square is equals to root 3. Then take compass, measure root 3 and draw an arc from that point to till it intersects the number line. Yes, where it intersects, that is called root 3 on the number line. Mark it as root 3 from 0. Now, we have drawn root 2 and root 3 on the number line. In such a way, we can draw any number of irrational numbers on the same number line. Now, for the representation of the following steps must be followed. Draw a number line and mark center point as 0. Step 2. Mark right side of the 0, 1 plus 1 and left side 0 as minus 1. Step 3. We won't be considering minus 1 for our purpose. Step 4. With same length as between 0 and 1, draw a line perpendicular to point. Step 5. Now join the point O and the end point of the new line of unity length 1 such that new line has a length of 1 unit. Step 6. A right angled triangle is constructed. Step 7. Now let us name the triangle as ABC such that AB is perpendicular to BC. Is the base of the triangle AC is hypotenuse of the right angle triangle ABC? Step 8. Now length of the hypotenuse, that is AC, can be found by applying Pythagoras theorem. AC square is equals to AB square plus BC square. AC square is equals to 1 square plus 1 square is 2. AC square is equals to 2 and AC is equals to root 2. Now represent root 2 on number line. Yes, we can draw some more irrational numbers on the same number line. Continue the next step to draw root 3 on the same number line. Let us observe the steps. Step 1. With same length 1 unit, draw a line CD perpendicular to D such that New line CD has a length of root 2 units and D is 1 unit. Join CE by applying Pythagoras theorem to thus triangle CDE. CE square is equals to CD square plus DE square. CE square is equals to root 2 whole square plus 1 square, that is CE square is equals to 3, CE is equals to root 3. Now represent root 3 on number line. Draw an arc from the point root 3. Yes, that's enough. Hi children, if anyone asks you to prove square of an even number is also an even number, assume an even number is equals to 2x. Square of it is 2x whole square is equals to 4x square, that is 2 into 2x square. This is multiple of 2 is an even. Hence, the square of an even number is always uneven. In above, we proved the required result using the general form of even number. Direct method it is called. Now, hi children, if anyone asks you to prove that the sun rises in the east, how can we prove? Can we go to sun? Which method is suitable to prove? No, we can't prove directly. This is an universal truth. Everybody knows it. In such time, we know but cannot provide directly proof to it. Then we have to adopt an indirect method, that is with logical arguments. Let us observe. Solution. Let us assume sun rises in the north or south or west. I observed whole month sun did not rise in the north. I asked my class teachers, no one said sunrise in the north. I asked my parents, they did not say sunrise in the north. I browsed the internet, no site agrees sun rises in the north. So my assumption is wrong. Hence, sun did not rise in the north. Only sun rises in the east. Our entire argument stands on predefined term direction, isn't it? Now, similarly, in mathematics, we use predefined terms, axioms, postulates, or theorems for our arguments. Prove that root 2 is an irrational number. Let us suppose root 2 is rational number. Implies root 2 is equals to a by b, where a comma b are co-primes, whole numbers, and b is not equal to 0. That is equals to 2 is equals to a square by b square by squaring on both sides, or a square is equals to 2b square. A is 2 times some other whole number. Symbolically, we can write a is equals to 2k. Here, a is even. Therefore, a square is equals to 2k whole square. That is equals to a square is equals to 4k square. Now, 2 star b square is equals to 4k square. B square is equals to 2k square. Hence, or here b is even. Is it contradiction? Why? We started the whole process assuming that a and b are co-primes, but here we get both have common factor 2. Therefore, root 2 cannot be rational. Hence, root 2 is an irrational. Prove that root 2 plus root 3 is an irrational. Let us assume that root 2 plus root 3 is a rational number. Implies root 2 where p and q are co-primes, positive integers, such that q is not equal to 0. Root 2 plus root 3 is equals to p by q. P by q minus root 3 is equals to root 2. Squaring on both sides, p by q minus root 3 whole square is equals to root 2 whole square. That is p square by q square minus 2 root 3 p by q plus 3 is equals to 2. And rearranging the terms, p square by q square plus 3 minus 2 is equals to 2 root 3 into p by q. That is equal to p square plus q square plus 1 is equals to 2 root 3 p by q. Here, p square plus q square by q square into q by 2p is rational, since p, q are integers we assumed. And right hand side, it is root 3 is irrational. Complete quantity which lies on the left hand side is rational and right hand side is irrational. It is a contradiction. This contradicts the fact that root 3 is rational. So, assumption was incorrect. Here root 2 plus root 3 is irrational. Prove that 3 plus 2 root 5 is irrational. Let us say 3 plus 2 root 5 is irrational. Then the coprime p and q of the given rational number where q is not equal to 0. 3 plus 2 root 5 is equals to p by q, and 3 minus p by q is equals to 2 root 5. Rearranging, we get 2 root 5 is equals to p by q minus 3 is equals to root 5 is equals to 1 by 2 into p by q minus 3. Since p, q are integers, thus 1 by 2 into p by q minus 3 is a rational number. Therefore, root 5 is also a rational number. But this confronts the fact that root 5 is an rational. Hence, we get root 5 is an irrational. Prove that root p plus root q is irrational. Let us suppose that root p plus root q is rational. Let root p plus root q is equals to a, where a is rational. Root q is equals to a minus root p. Squaring on both sides, we get q is equals to a square plus p minus 2a root p. That is implies root p is equals to a square plus p minus q by 2a, which is contradiction, as the right hand side is rational number while root p is irrational, and hence root p plus root q is irrational. The sum or difference of rational number and an irrational number is irrational. By definition, an irrational number in decimal form goes on forever without repeating a non-repeating, non-terminating decimal. By definition, a rational number in decimal form either terminates or repeats. Example, 3 plus root 5 is equals to 3 plus 0.236067977 is equals to this is irrational. And 4 1 by 3 plus pi is equals to 4.3333 etc plus 3.141592653 is equals to 7.4744925986 etc. is irrational. If you multiply any irrational number by the rational number 0, the result will be 0, which is rational. However, of irrational times an irrational will be irrational only. A better statement would be the product of a non-zero rational number and an irrational number is irrational. For example, 3 by 4 into root 2 is 3 root 2 by 4 is an irrational. And which is an irrational number? The product of two irrational numbers can be rational or an irrational depending on the two numbers. For example, root 2 into root 2 is 2, which is rational number. Whereas root 2 into root 3 is equals to root 6, which is an irrational number only. Write 3 examples for the product of two irrational numbers is rational. Write 3 examples for the product of two irrational numbers is irrational. Thank you.